Okay, I suppose we should get started. Lecture 7, lab today. We're going to stay inside. You've got your disadvantages of bad stall design list is due at the start. And then we'll take some computer time showing you how to do flow charts and diagrams, and we'll use the bad stall design for that, and then pivot tables and graphs for your time assignment. So if you have your data and you want to put it in the spreadsheet I posted up on Blackboard, you can work with your own data set moving forward. Any questions or concerns? So last time we were talking about waterers. We left off with calves and water. One of the big questions, at least in this part of the country, is water provided at all? I think most farms are doing it, but not every farm. They're assuming, particularly in the winter, that they're getting all their liquid, all the water they need from the milk they're consuming, which this time of year might work, but we want to find out whether it is or not, and that's going to influence rumen development, especially in the summertime. So we need to provide water. Again, this time of year is tough. As we talked about up in the calf barn there, things freeze pretty quick. So trying to provide that water on the off hours away from milk consumption. Is the water clean? With the calves, we asked, is the water too close to the feed in those single housing pens? When we get the situation where the calf's nose can go from one to the other and back and forth, they usually get a lot dirtier, and the water gets a lot dirtier and the feed gets a lot wetter, and that leads to mold issues in the summertime, and we need to clean things more often. Calves, we're looking at a few gallons a day by 3 or 4 weeks or so. As we get hotter, temperature goes up, we're going to push that few gallons in the winter. Maybe it's only a gallon or so. We want that water there in addition to the water of the milk for rumen development and for successful weaning. We can get that rumen developed the way it should, running the way it should with the water we provide. Weaning is going to be a whole lot easier for that animal. So we looked at these a little bit in lab. So guidelines for water systems. We want fresh, ample water, as much as they need. So the question is, how much do they need? We need to clean that water frequently to encourage intake. And we want to have that separation of the water and feed buckets. So either by distance, putting them in different locations, or you've got a physical barrier. The vertical bars, they come in here, they have to back out, come over, and come in on the other side. So either that, or you put some sort of physical barrier between the two, making sure that the animal has to drip or drop all of her stuff around her nose before she gets to the other one. So you have this in your facilities handout. So when we're thinking about water in our pens, we need to think about clear paths for animals to resources. Can they get to water? Can they get to feed without obstruction? We want clear paths. We want multiple access points if we can, or from multiple directions. Every time we have a situation where cows are bumping into each other, that brush bump, there's a chance of displacement. So you guys, I don't know if you're part of your growing up is going to the mall and hanging out at the mall. Is that something you guys did or not? Not really, a little bit? Well, you notice in particularly the larger stores at the ends of the malls, the Macy's, the J.C. Penney's and stuff, they try to have pathways where you're moving through, and then they have things where they try to slow you down and prevent you from being bumped up against with other people. So you get kind of in these little cubby holes. They can hold you there. They can talk to you there. Whereas if you were in that main traffic, it's harder for people to stop. You start looking at how stores are laid out. You start to see that they're thinking about those things as well. If a person or an animal is likely to be bumped against, they're not going to stick around or stand around. And that's going to, at least in a store, lead to you probably buying less. So you want to be able to get people to stop, get animals to stop. So pass to resources. We'd like to have multiple resources if we can. We'd like to have multiple approaches. So kind of the open pen design. You're seeing that in robots. It used to be that the robots were designed where animals had to complete a through one-way gates to get milked. Now places are going to more of an open design. Let the animals go in whatever direction they want. Let's not restrict them. Let's not limit them in one direction or another. So if you want to pull out your water systems fact sheet, we can. It should be in your original facilities handout.
Oh, okay.
So I know I've printed things out multiple times, but you should have one in there. So water is consumed several times a day, associated generally with feeding. Cows eat and then they drink, or when they get done with milking, there seems to be a tremendous drive to drink. So providing water at those times is going to encourage or increase water intake. Having water readily available at those places at those times is probably pretty important. Insufficient water intake, we kind of alluded to this in lab. Abnormally firm manure for that group of animals or that individual animal. If you can figure out decreased urine output, that may or may not be a little bit more difficult to sort out. Feed intake, you should have a pretty good handle on that. Decreased milk production, all might be associated with some sort of decrease in water intake. So depending on how you do it, I know we had, growing up, there were certain barns where it was a manual operation, getting the water to the animals. That was a lot of extra work, but it still can be done successfully. And then making sure those containers are clean. You've got fresh water in them, and then this time of year, making sure that they are open and accessible. So going through and making sure things aren't frozen up or iced over is pretty important to make sure we have what we need to. It seems up at the barn, anytime the temperature goes below zero, we have some problems with the waterers in maternity. The heater in there is a light bulb. I don't think that's probably the best approach, but we increase the wattage to see how well that works. And then there's some other ones down in the lower heifer barns that usually freeze up kind of regularly. And that can be a challenge that we need to address to make sure those animals have at least one source of water. So we talked about how animals want to drink, that posture, allowing them to drink in a natural position. Sometimes you get those drinking cups. Some people call them drinking bowls. Where I grew up, they were drinking cups. Their position is the nostrils are underneath the water as they push things down.
They don't seem to like that nearly as much if they can get that kind of tilt going in and getting their jaw opening up, keeping their nostrils clear of the water. So getting those long draws of water is going to encourage or promote more water intake. So I think we showed this in lab. So you're looking at, with your heifers, 6 to 15 gallons, thinking about how they might get that. Dry cows, probably 20 to 30, and probably 30 to 40 is a better number for those milking cows, at least when I've measured metered water to animals across the day, rarely get above 40. So we said that 50 is related to the gallons of water we need to clean the milking system and run the farm. So using 50 gallons per animal per day will start to get you the water requirements you're going to need to run that farm. So how do we increase water intake or water access? We either give more sources, we increase the pressure and flow rate, or I think a lot of times just making sure things are cleaned. Certainly in the summer, once a day is probably a good approach with our lactating cows. If we can make that happen, there are a lot of waters that are very hard to clean. You've seen those big deep tanks with the goldfish in them and stuff, algae. Those are usually a lot harder to clean than some places have tip tanks. Has anybody ever seen a tip tank? You just go right in the pen. You come, it's got a big long handle. You unhook it, tilt it. Usually there's a brush right there for the people doing it. Tilt it back, lock it in place, and that is taken care of. The downside on that might be, how's that going to influence your water system or your manure handling system? That much extra water in the system, but it's probably the equivalent of what a cow urinates in a day. So if you keep things not too big, there's an opportunity to not really influence the amount of manure you get out of the system. So we talked about the physical distance, separating those animals in the calf system. Kind of a list, kind of specifics to what we're looking for in cattle in pens, cattle in tie stalls, or we have the troughs. Has anybody seen in a tie stall system where they put in a trough system up top? So they take a big diameter piece of PVC usually, they set it up on top of the front, and they have a float system, and then they'll run that trough the length of the barn for water in a tie stall system. So what can you think of might be some of the challenges with that type of system? What? Okay, it might be pretty sloppy if you got that trough up top. What else might be an issue with that? Probably the biggest challenge with that is whether the barn is level or not. If you're going to put those from one end of the barn to another, one continuous trough, it's got to be level from one end of the barn to the other, or you're going to have all the water down at one end and not the other end. So the weight becomes an issue. Do you have a support system that will lift all that up? Head space when a cow is standing up, where does she put her head? If you've got that big trough in the way, that might become an issue. Usually it's up above lunge space, but as it goes up higher, to get out of lunge space, to get out of the way of the feed space, you've got a more unnatural position that you're dealing with. So they're getting their head higher up, and you're not getting that tilt that those cows like. So with our pens, We discourage the bowls or cups for groups of cattle. We want 2 inches of water space per animal, at least 2 water sources per pen. And we want to be able to have clearance around those waterers so the animals can move up and not be bothered or pushed away by animals moving on to other parts of the pen. So we've got some height requirements that we suggest. If they get too low, we get animals standing in them. They get too high, we get a more unnatural position for water consumption. We'd like the water to be down a little bit to keep the slop to a minimum, but at the same time, we'd like that trough to be long, shallow, and fast filling. So we went through this worksheet with calves. Again, the green stuff, when you're talking with a client, if you're using this, the green stuff means we're doing things well. The red answers there's an opportunity for improvement and opportunity to discussion with the client. So hopefully you have some way to do that that's not too expensive, but there's an opportunity to say, hey, we can encourage water intake. So same thing with our pens. We went through this sheet in lab. So we're kind of going through the checklist of things we're looking for, making sure we've got a trough or a tank, more than 2 inches, more than 2 inch water sources per pen, more than 2 inches per animal. Is there any indication that water intake is insufficient? Looking at your cows, how they're responding. Is there any indication that suggests those cows are not consuming the water they could? And then making sure we've got space around that water. A good cross alley is a good place to put it. Open space that can approach that water from multiple directions. So we're also looking at opportunity space to make sure things are drinking. So the distance from feed to the water system, that should be 50 feet, not 6 inches. So if you want to make that correction. So right here, distance from the feed to the water, less than or equal to 50 or 45 feet, whichever one you want to do. That's a mistake. Is the system designed correctly? Do animals line up or have to wait to drink? So there are farms I've been on where everything is kind of synchronized and those animals are fighting over water at the same time. So that usually means some are going to get what they want and others are not. So we have less consumed across the whole herd. So is the water system functioning properly? Is there sufficient water pressure that when animals, multiple animals are drinking like they would as they come back from the parlor in the summertime, that those tanks fill up fast enough that cows are not standing around waiting for water to come in. So we'd like that to be there. So tie stalls, we talked about the different things we're looking for. What have we got? We got some sort of trough or tank in the front, or do we have a bowl or a cup? How many animals are on that water system? Thinking about whether or not the water intake is sufficient. Where are the drinking cups located? Are they the right height? Or is there enough space for them to get their head in? I've noticed on some farms, tie stall, bigger animals have trouble fitting in if we put those in a stall divider, or there's an opportunity for them to, they have to kind of tilt their heads to get in. Making sure those water cups are clean, free of feed debris, cleaned out on a regular basis. free of that black algae that grows in there. So hitting them with Clorox every once in a while will slow that down. Making sure the system is functioning properly, and then if you let your cows out like you're supposed to, they all come in the summertime. Are they all hitting water at the same time? And if they're all hitting that water at the same time, are the ones on the ends of the line running into trouble or not getting water versus the ones that are closer to the pump? So making sure there's sufficient flow, sufficient pressure, that when a whole lot of animals are on the system, that everything gets taken care of. If the cows have to fight for the water, if they don't like the smell of it, they're less likely to consume. So that was sort of review. Calf housing fact sheet. So putting together calf housing, a little bit different than our mature cows. We're going back to the front of the manual, if I'm not mistaken. We really should have put page numbers on these. Everybody find that up in front. So what kind of system do we have? Do we have hutches? Do we have a bed and pen? Hutches. Generally, if we can keep the animals warm, either through blankets, good bedding, or coats, they do very, very well outside. The ventilation is pretty good. So we'd like to have some sort of system where we keep that animal associated with that hutch. So fences have their advantages and disadvantages. This time of year, they tend to get frozen to the ground, and that can be difficult if they're tall enough. For some of us, getting in and out of those there, if we have to treat an animal, handle an animal can be a challenge. Other people have tied the animals up with chains to the post. The general consensus is your attachment point for a chain is usually low. At least people I've talked to, if they put that chain up high, there's a chance the animal might get entangled and hang themselves in it, where that seems to go away if you put your attachment point on the chain low. We'd like to break the cycle of disease, if there is one, having our hutches sit idle. If we can flip them over, let the sun hit them, especially on the inside. There's some real advantages to that. The UV light from the sun is a great disinfectant. In the summer, we have to be careful that they don't turn into a greenhouse. And then we have to deal with animals dealing with too much heat. Has anybody dealt with, what would that be, hyperthermia in animals?
I have one, but she died.
Okay. So hyperthermia, I know I worked on a game bird farm. One of the cheap ways to house them at night was these greenhouses. They're pretty short, and you did the hoops and you put the plastic on them, but you had to make sure you chased them outside during the day because they were too stupid to leave on their own. So usually about mid-morning, you made sure all the ducks got pushed out, because you had a translucent thing there to get up on a sunny day pretty hot in those greenhouses, and that was too hot for those animals to survive. So we needed to make sure that we pushed them out into the sun. There are other shade things outside, but those greenhouses were pretty cost effective on a colder winter night or a overnight chilly where we were. You dealt with some chilly nights. So making sure there's ventilation in these places, making sure that you've got heat not building up in some way. So depending on what they are, some have vent systems in them. Sometimes you'll have to build your own. So there's a suggestion with hutches that we face them to the south or the east to get that sun in there in the morning. If we face east, to warm that calf up faster after a cold night. But generally we're dealing with prevailing westerlies, so we don't want the wind blowing right into the front of a hutch. So keeping away from a west-facing hutch or a northwest wind is usually really cold. So facing south, facing east for draft protection. Individual tie stalls. These are generally done with warm housing only, so there's a supplemental heat source in that barn, usually a radiant heat of some sort. This can get rather expensive, and ventilation becomes a real challenge in those places as you've got more heat evaporating things, and if you don't turn over that air, you're going to have all kinds of smells and vapors in there that you don't want cows breathing. But at the same time, you've just warmed up that air and you don't want to send it out. So making sure that you've got adequate ventilation, adequate sanitation. And with any of these, if you can come up with a system that requires a lot less hand labor, that is a little bit more automatic, that I can come through with a skid loader, clean things out. If I have to do everything with a shovel, a fork, and a wheelbarrow, things don't get done as efficiently or as often as they might. We like to have solid dividers between the animals that can reduce drafts, but also nose-to-nose contact. It would be nice if we could do all in, all out, at least in sections, to reduce that pathogen buildup. But leaving things idle usually means we have to build things bigger, and they're more expensive. So you've got to do your trade-offs going through. So bedded pen, starting with those animals. We've got loose housing. We want to certainly start them out with solid partitions, making sure we're ventilating in the right direction. Yes.
Are the ones up at the dairy considered bedded pens, even though they're
Yes.
like they're separate or not?
They're bedded pen, individual bedded pens
Like
as
they're not like
opposed
this
to.
picture.
So they're not tied, so I consider them individually housed. So you've got a small pen. We could, in theory, take the partitions out, although they're really not designed for that. Make 3 or 4 animals together over time. I know Calves and Heifers has done some experiments where they figured out how to take partition out and did 2 together.
I just wasn't sure if it still counted as a bedded pen.
It's murky, but yes. So from a wording standpoint. So again, if we get some idle time in our pens, clean them out, let them sit for a while. We usually have better pathogen control, better morbidity control, but keeping things idle is a little bit more expensive going through, but from the health of our animals, that usually works out much better for the animals. As we get into transition heifers, we start to group those animals together. And we're looking at 24 to 30 square feet per animal. I think about a standard sheet of plywood. So we had this discussion a few years ago. I said a sheet of plywood. When I think of plywood, I think of 4 foot by 8 foot. But there appears to be a lot of different sizes of available plywood out there. So I make sure I say that 4 by 8 plywood. If I lay that down, that's usually the space required per animal or something close to that. So what you're looking for, what you're trying to achieve per animal. So worksheet, we're kind of looking through with your calf housing. Again, the green yeses are what we want. If we've got no, there's an opportunity to have a conversation, opportunity to say, hey, if you've got sick calves, if you've got dead calves, this might be your problem. So working through that, clean and dry, we go through that over and over again. So are the calves clean? Are the calves dry? Is the bedding clean and dry? If you've got those no's, we're looking to revise your bedding management so those animals stay dry and clean. How's the ventilation? We need to improve that. How much space is allocated per animal? So we're looking at standard sheet of plywood kind of size. You get out into California, they really shrink that down. Bedded pen, we might have a little bit more, a little bit less per animal as we try to get a little bit more efficient. Tie stall, we're looking at an animal where we're controlling her posture, keeping her nose in the same position. They're not really turning around. And then as we get into transition, we hold to that 30, 32 square feet per animal. So if we're looking at our transition animals, are they grouped properly? And this can be a challenge sometimes. We're trying to keep them within a narrow range of size, and we usually do that when we're dealing, or usually start with age as our grouping mechanism. You're probably looking at something that's less than a month. If we've got a farm that can generate 6 calves within a month, that's really great for grouping. If they're more spread out than that, we don't have as many, it gets harder and harder to group those animals kind of uniformly. So if the animals are not all uniform within a pen, we need to think about what we could do differently. Bigger animals tend to monopolize resources at the expense of the smaller animals. So how do we handle those facilities between animals? What is our disease control like? Do we disinfect with something? That's gotten really expensive as we compete with people wanting to clean their houses and things like that. There's expensive, at least like DCNR is some cases 4 times what it was in price. Do we have something we can do that? Do we leave facilities idle? How long? Do we give that an opportunity for those bacteria to die, to be destroyed, become inactive? Do we have nose-to-nose contact? If we don't have it, that's pretty good. More people are going to pens. So are we making sure that we're feeding those animals, housing them well enough, clean, dry, well ventilated, to keep those animals from getting sick and passing everything to their pen mates? So respiratory ailments, digestive ailments, 2 main causes of problems with our calves. And is there anything that we can do related to housing to slow those things down? So ventilation, clean, dry animals. For respiratory, digestive ailments, trying to keep things as clean as we can, making sure that our maternity is what it's supposed to be. everything clean and dry. Heifers moving up a little bit in size. We kind of looked around at our heifer groups, but here's some recommendations with kind of a freestall housing. So we've got putting those together. We're trying to put a system that is cost effective and allows all the animals to get their equal share of feed. That can be a real challenge with our heifers because it doesn't take them very long to wipe out what's there. Trying to do that low calorie, low energy density, low protein density diet is tough with the forages we have in New York. We've gotten pretty good at that. So it's having enough bunk space for all the animals to eat at the same time can be a real challenge with the barns we built, especially the 3-row barns. So do we have a barn that's easily cleaned, is easy to get feed to, and clean up that leftover feed going forward? We have to handle our heifers at certain times throughout their life. Is that an easy process? Feed them through a chute from one side of the pen to the other? Or is it involve several people, maybe a dog, maybe a tractor, and a couple of rodeo clowns to get that done? The easier it is to do things, the easier it is to treat those animals, breed those animals, measure those animals, the more likely it is to get done. The more people that are involved with something like that, the more planning is necessary, the more things that have to happen to make sure things work out right. So we can think about multiple rows, bedding pack, outside. If the weather conditions are good, the challenge in New York is the mud season on either side, keeping those animals clean, keeping them dry if we've got them outside. If you provide a windbreak to heifers housed outside, they can usually handle most of the temperatures that they will encounter. You also have to provide a windbreak and enough feed that they can generate the heat that they need. Heat that they need to stay warm. So if we're housing animals outside, it's going to increase our feed costs if we're doing it right, trying to make those animals continue to grow. So we're going to have increased variable costs, but maybe we have decreased building costs. So if we're looking for different sizes here, as we work our way up through the heifer system, how many square feet per head do we need in a resting area or bedded pack area? So we start out at 40 for our 400-pound animals. We work up to 70 feet per square feet per animal as we work past breeding. Paved outside, you got some sort of lot out there. How much area do we need for exercise? Self-cleaning resting area. Has anybody ever heard of a self-cleaning resting area? They're also called Virginia slope barns. Has anybody heard of those? So notice that as we get down here to this self-cleaning, there's a lot less square foot per animal. And the idea behind these barns is that we're trying to use gravity and the action of the cow's hooves to clean the barn out. So I guess taking full advantage of the phrase shit flows downhill. So we'll show you that in a minute. If we're putting together freestall dimensions, what are we looking for those 4 sizes of animals? How much lunch space? How much to the brisket locator? How much to the neck rail? neck rail height, upper dividers. As those animals get bigger, we are trying to fit those animals with the stalls they have. If they don't fit, we can run into some issues with animals getting dirty, getting caught. We had an animal over the weekend up at the dairy. She got caught in a stall and was probably there, we figure, for 12 hours. So by the time she got up, her legs were pretty numb. So she's spending a little time in maternity till she gets her feet back underneath her. So size for the animals, as we go from left to right there, we are getting bigger. So heifer housing worksheet. So taking that information we had on the other ones, what is it for this farm? What do we recommend? What is necessary, or what is available for those animals? There's a range there, noting that, okay, it might work if it's on the smaller end, but maybe if we're building new, we might be moving toward the higher end. Again, anytime we make our stalls bigger, our pens bigger, we're gonna have more building space, and that's gonna cost more money. So we're looking at our groups of heifers. The first thing we want to say is, are our heifers uniform in size within the group? So we would like them all set that way. If not, we might recommend or consider that we regroup those animals, or at least move the small ones down to the next group. Figuring out a system, figuring out a sorting, that given this space, we can have 3 or 4 uniform groups. Up the dairy, the lower heifer barn, we're looking at 3 uniform size groups as best we can. So is the number of animals, once we got them all the same size, is the number of animals appropriate, given the stalls, given the spaces we've allocated? Is that the right number of pens? We see a lot of overstocking with our heifers, especially as we're working to expand and make that next leap or next cow size better, trying to grow internally. And it's easier to get or justify milking stalls than it is to justify heifer stalls. So there are a lot of places. We are very understocked up at the dairy right now. There's a lot of places out in the world where heifers might be pushing 200%. So are the stall dimensions right? Do we have restraint systems that allow us to handle those animals and do what we need to do? So if you can get those 4 questions answered yes, we're looking at proper facilities for our replacement heifers. And again, that's always a challenge to make sure that those heifers are taken care of. So finding the money to make sure everything happens the way it's supposed to can be a challenge, especially if we're not planning things out and thinking more long-term, being proactive instead of reactive. So space needs, we showed those already. And again, those self-cleaning areas, significant reduction in the feet per square head. So what's meant to happen, if we look at those Virginia slope barns and the self-cleaning barns from the side, this is kind of the ground level here. You got the roof up there. Those Virginia slopes, they're meant to face south, that they catch the sun, particularly in the winter time. Now, their snow issues are not going to be nearly as aggressive or deep in Virginia as they are up here in central New York. And as we get farther, this problem farther north in that lake effect area, it's not going to work at all. Well, the idea is that there's usually a road here. We can drive by, put bedding in these stalls, so clean bedding goes at the top. As the animals come in, we get a high concentration of foot traffic. As they step, everything they step on moves downhill. So if we've got our spacing right, our numbers right, this should slide all the way down, be completely soiled by the time it gets to the bottom. We come through, push everything out with a tractor. There's usually a system of gates where we lock the animals up in the bedded area. It's pretty aggressive from a slope standpoint, but the idea is that you're getting the animals to turn that bedding over by the action of their feet. And when it gets down to the bottom, it needs to be removed. We've got the same sort of thing on the feed line. They're sort of standing uphill. But again, the manure is going to work its way down to that center alley. If we can lock those animals in at the feed line or the bedding area, we can come through and clean things out fairly quickly. So higher density associated with this barn, bedding comes into the top. As it works its way down, it gets more and more soiled. By the time it gets to this alley down here, it's time to get rid of it. So pushed out to the end, we have these gates here. They can swing and push those animals up there. Series of gates. Should be able to come through fairly quickly. Swing those gates up. We've got all the animals up in there, and we can just run through and clean that area with relative ease. Not a lot of handwork. The challenge would be, if we're not doing it on a regular basis, how much gets pushed up into those bedded pack areas. So higher stocking density, more animals per unit of area is going to allow that to work. If things freeze, that becomes a real issue. You're not turning over things the way they should. So again, Virginia, Maryland, these seem to work a lot better than up here in our part of the world. I'm going to stop there. We went through the worksheet in lab. We'll walk through that next time and talk about flooring. So remember, for lab this afternoon, bring your laptops so we can work through and get done what needs to get done.